All right, Ether Channel fans, some important notes here to finish our Ether Channel discussion in our lab. Ports in an Ether channel should be running at the same speed and duplex, as well as be configured to use the same native VLAN and the same list of allowed VLANs. Now those last two are of course for Ether channels over trunk ports, which is what we configured here today, and that's generally what you're going to be doing in the field. If you are configuring an Ether channel with access ports, they have to agree on the single access VLAN. Now, the odd thing is that a mismatch here with some of these features, especially native VLAN, it doesn't necessarily mean the Ether channel won't form. It doesn't necessarily mean your trunks won't work. It's just that they're not going to work really well. And also, you should get a message just screaming bloody murder, frankly, about what the problem is. And that message is going to look something like this. And as a matter of fact, we have 12 messages now. I just configured this a couple of minutes ago, I should say. And you can see by the timestamp that every minute we're getting 3 messages. Hey, there's a native VLAN mismatch on fast 10 and 11 and 12. It even tells you what the VLAN is, because you can see right here, I changed the native VLAN to 5 on switch 1 after I got rid of the Ether channels. And you can see right away it's telling you, hey, and it spells it out for you. It even tells you what the mismatch is, because right now it's saying native VLAN mismatch discovered on fast Ethernet 10, 11, and 12, and it's telling you right there it's 5, and then it's saying, hey, switch 2 on the other end, and sometimes you have to go to the very end of the next line to see what the native VLAN is, but it's saying on the other side it's 1. So that's something you would definitely want to fix. Now, as far as those Ether channel negotiation protocols go, we have PAGP and LACP. I'm just going to tell you a little bit about these, and I'll show them to you on the live equipment. These are your 2 Ether channel negotiation protocols. PAGP, the Port Aggregation Protocol, is Cisco proprietary, where LACP is the IEEE standard or the industry standard. PAGP offers the desirable and auto options, and LACP offers active and passive. So if you're running PAGP, one of your 2 sides at a minimum has to be desirable. Because if they're both sitting there in auto, they're both sitting there saying, okay, I'll form an Ether channel with the other end of this line, but the other end has to go first. Well, you got 2 wallflowers then, right? If they're not asking each other to dance, they're not dancing. Same goes with LACP and active and passive, where passive is the one where the partner is waiting for the other end to initiate. So again, with PAGP, one end at least has to be in desirable. With LACP, one end of each link has to at least be inactive. Personally, unless there is some overriding reason that I have to use one of these protocols, I just turn it on. Frankly, it's a whole lot easier to work with, and a lot less troubleshooting comes in. Now, I know we're going to have these messages, but let me just show you where those options are. And you can see here, they're at the end of the channel group command after mode, where we just used on. You could use active, auto, desirable, or passive. I doubt your exam goes into that much detail, but it's a good idea to know them. Anyway, again, that's LACP and PAGP, and you see the options here, desirable and auto for PAGP. For LACP, it is active and passive. That is it for Ether channels. It is on to BPDU guard, and we'll see what we're guarding in the very next video. See you there.